Good morning, class 9th. Today we are going to discuss further about logarithms. We told you that why do we need to complicate mathematics, which is already very complicated for children. Logarithms is a mathematical tool which makes processes simple. We discussed that also calculators and computers have made things very simple for you. But even then, there are certain mathematical tools which we will be using time and again in mathematics, and one of the most important of them is logarithms. Now, what does it do? Logarithms is a mathematical tool which converts difficult processes like multiplication. Multiplication is more difficult than addition. So what it does is that changes multiplication into addition and division into subtraction, so that it simplifies. We have got laws which will change multiplication to addition and division into subtraction, and certain other aspects of logarithms are there, which we are going to discuss now. For example, the first one is called the product law. It is the product law. What is the product law? Like I've written on the left, you can see log m into n to the base a. This is multiplication of two terms, m into n, m and n. This is the multiplication of the two terms, m and n, to base a. Now this multiplication, it's looking very simple, but if it is very difficult, the numbers are very big or the numbers are really very, very small, it becomes difficult. To simplify them, logarithm introduces a formula, like it changes it to log m to the base a plus log n to the base a. Now we have changed the multiplication to addition. We have changed the multiplication to addition and it becomes simple. So with the help of the product law, we can change a product into an addition, like log m into n to the base a is equal to log m to the base a plus log n to the base a. And please understand, this is not only for two numbers, there could be multiple numbers, like if it is log m, n, p, q and so on to the base a. It is not only, as I said, it is not only applicable when two numbers are multiplied, there can be multiple numbers which are multiplied with each other. That is what I said, difficult processes, long multiplication, long divisions can be simplified into addition and subtraction. So this multiplication of many numbers can be written as log m to the base a plus log n to the base a plus log p to the base a plus log q to the base a, and so on. Whatever the numbers are there, we can change that many numbers, that many multiplication into addition, basically extending the first formula, the product law. So multiplication can be changed into addition with this logarithms. Second one is the quotient law. What is the quotient law? Like if it is division, log m upon n to the base a. If it is log m upon n to the base a, then I can change it into subtraction, like I can write it as log m to the base a minus log n to the base a. So division changes into subtraction. Then we have another law. You must be wondering why it is not like this. Because it will apply the same thing. It could be multiplication also, could be multiplication in denominator. The same combination of these two can be applied. If they are in the numerator, they will be multiplied. If they are in the denominator, they will become minus. Whatever the numbers are in the numerator, for example, if it is m into n into p, suppose upon c into d, and I want to take the log of this. I want to take the log to the base a. Then whatever is in the numerator will become log m plus log n plus log p to the same base a, and this c and d will become minus log minus log c minus log d. So we can convert this, we can combine the above two laws into single thing also, and this will be used in calculations. When we do longer calculations, it will be used. The next is the power law, like log m to the power n to the base a. Now this is both, this is also same way. It is applicable. Log m plus log n can be written as log m into n. Log m minus log n can be written as log m upon n. Log m plus log n plus log p plus log q, so on, can be written as log m into n into p into q. It is a kind of reversible equation. Log m to the power n to the base a will be equal to n log n to the base a. This power comes in the beginning. This power comes in the beginning. All the power from here can be taken here. That's the same thing. Like if I take this power, I'll get this. If I bring this power here, I'll get this. So in the power law, the power is brought in the beginning as multiple. It is brought in the beginning as multiple. This is the power law. This is the power law. Now the base change formula. That if you have to change the base of any logarithm. For example, he has given you log m to the base a. I want to change the base of this from a to something else. So what is the formula? You just write log m. Remember just now, I'll be explaining it further. And log a. Log m upon log a. And then whatever the base is there, write the base here. Whatever the base is here, base will come here. So we can change the base of any logarithms by this formula. The last formula which we were discussing was about change of base. If we want to change the base of logarithm, for example, here it is log 50 to the base 2 is equal to n. Like log 50 to the base 2 is equal to n. From logarithm, let us change it to index form. I told you that when we change it to index form, it will go like this. 2 to the power n is 50. This is the log. The exponent is always the log. So 2 to the power n is equal to 50. 2 to the power n is equal to 50. Now let us take the log of both the sides. Let's take log of both the sides of this equation. What I have equation 2 to the power n is equal to 50. Let me take the log of both the sides. When I take the log of both the sides, it becomes logs 2 to the power n log 50. Now whatever base you want to change, that base I have written here, x. Both sides the bases will be the same. Log 2 to the power n to the base x, log 50 to the base x. This is the basic, whatever the base you want to change it, you will bring the base both here. Log 2 to the power n upon base x, log 50 to the base x. Now, this according to the power law, n will come here. N log 2 to the base x is equal to log 50. Or n will be equal to log 50 to the base x upon log 2 to the base x. N comes out to be log 50 to the base x upon log 2 to the base x. And what was the value of n? N was log 50 to the base 2. N was log 50 to the base 2. So log 50 to the base 2 has become log 50 to the base x upon log 2 to the base x. So we have been able to change the base of this given logarithmic form from 2 to x. X could be anything. X could be any number. For example, let's take one more example for this. Log 125 to the base 3 is equal to n. Suppose it is given log 125 to the base 3 is equal to n. Let's change it to the index form. 3 to the power n is 125. 3 to the power n is 125. Let us take log of both the sides. Log of 3 to the power n is equal to log 125. And base is above y. Both side base will be same. Any base which we want to change it to. So we have taken the base y. I want to change the base to y. So log 3n, 3 to the power n up to the base y is equal to log 125 to the base y. Now again, power law. The power will come as the multiple. It will become n log 3 to the base y is equal to log 125 to the base y. So n will be equal to log 125 to the base y upon log 3 to the base y. And what was the value of n? N was log 125 to the base 3, while n was log 125 to base 3. So log 125 to the base 3 will be equal to log 125 to the base y upon log 3 to the base y. So it is simple method of changing the base of any logarithm. Like if I want to change the log 50 to the base 2, if I want to change the base, then I'll write log 50 upon log 2 and whatever the base I want to change. For example, here I wanted to change x, so log 50 up to the base x upon log 2 to the base x. Let's solve few problems based on whatever laws we have discussed just now. Like first question, he says express log a square c upon under root b to the base 10. Even if the base is not written 10, then it is taken as common logarithm to the base, common logarithm as to the base 10. It is accepted norm if 10 is not written, that means you accept it as the base 10, otherwise he will write the root. Otherwise he'll write the base. So it is log a square c upon root b to the base 10, though he's mentioned the base 10, to express them in terms of log a, log c and log b. To express them in terms of log a, log c and log b. So what are we going to do? Next step would be, because in the numerator a square and c are multiplied, so they will get added. That is log a square to the base 10 plus log c, because multiplication changes to addition. Multiplication changes to addition. Whatever is in the denominator, that means it is dividing, division will change into subtraction. That will become log under root b to the base 10. Now it is log a square to the base 10 plus log c to the base 10, and this is log b to the power half. The square root means to the power half to the base 10. The powers are brought in the beginning as multiples, power law. This 2 will be brought up here. It will become 2 log a to the base 10. So now I have expressed it in terms of log a plus log c to the base 10 minus half log b to the base 10. We have been able to express this in terms of log a, log b and log c. What have we done? Multiplication we have changed to addition by logarithms, and division we have changed into subtraction by the laws of the log. So log a square into c upon under root b to the base 10, as I told you in the beginning that he has mentioned the base 10, but if he does not mention the base 10, that means we are going to consider as to be the base 10, because common logarithms are taken to the base 10. So log a square to the base 10 plus log c to the base 10 minus log under root b to the base 10. Now log a square to the base 10 plus log c to the base 10, and this under root is changed to the power half, b to the power half. In the next step, I'll bring the powers as multiples in the beginning. Like it was 2 by power law, I will bring this power as the multiple. 2 log a to the base 10. Here there is nothing, so it will remain log c to the base 10 minus half log b to the base 10. So we have expressed log a square c upon under root b to the base 10 in terms of log a, log c and log b. Now let us see the next question, which it says evaluate. Evaluate, the first a part is 3 plus log 10 to the power minus 2, 10 to the power minus 2 to the base 10. So again we are going to write it as 3, and I will bring this here, the power, that is minus 2 log 10 to the base 10. Because power comes in the beginning, so plus into minus will become what? Minus log 10 to the base 10. And you know log 10 to the base 10 is always 1. Log 10 to the base 10 is 1. So 3 minus 2 as log 10 to the base 10 is 1. Why? Because 10 to the power 1 will be equal to 10. So that is why it is 1. That is why it is 1. It is correct. 3 minus 2 is 1. The value of 3 plus log 10 to the power minus 2 to the base 10 is equal to 1. We have evaluated this. Now let us see the B part of this question, second part, that is also evaluation. And when we want to take out the value, the B part of this is 5 plus log 0.001 to the base 10. So 5 plus log, now this will be 1 upon 1000 to the base 10. You remove the decimal, we remove the decimal, so 1 will be written here and 1, 2, 3 zeros are written afterward. So log upon 1000, 1 upon 1000. So it will become 5 plus log, this will become 10 to the power minus 3. Because in the denominator it will be 10 to the power 3. When I'll take it to the numerator, the index, sign of the index will change. It will become log 10 to the base 10 to the power minus 3. And then I'll apply the power law, and this minus 3 will come in the beginning. 3 log 10 to the base 10. And again log 10 to the base 10 will be 1. So 5 minus 3 will be 2. We get 5 minus 3 equal to 2. Like 3 minus 2 was equal to 1 here. So we have been able to solve question 2. Now let us go to question number 3. Let's go to question number 3, which says simplify log 125 upon log under root 5. Since he has not written any base, that means it is natural logarithm. That is, it is the common logarithm. This is to the base 10. This is to the base 10. Natural logarithm is something different. So log 125 to the base 10, log root 5 to the base 10. Common logarithm is there. Log 125 can be written as log 5 to the power 3. This is written as log 5 to the power half, because under root is to the power half. Now let us apply the power law. If I apply the power law, it becomes 3 log 5 upon half log 5. Because the power will come in the beginning as multiples, here half will come as multiple. So it will become 3 divided by 1 upon 2, because log 5 will cancel. It will become 6, because 2 will go up. So 3 2s are 6. So value of log 125 upon log root 5 is 6. Now let us see the next question for log 72 to the base 6. Now he has mentioned the base 6 minus log 2 to the base 6. Log A minus log B. Log A minus log B means log A upon B. It means log A upon B, and both the bases are same. That is why it can be done. So log 72 upon 2 to the base 6. It will become log 36 to the base 6. Why 36? Because 72 divided by 2 will give you 36. And then it will become log 6 to the power 2 to the base 6. 2 will come in the beginning. It will become 2 log 6 to the base 6. And any number to its own base, the same base. For example, it is 6 to the base 6. It will become 1. It will become 1. Why? We told you log 10 to the base 10 is equal to 1. Because 10 to the power 1. What should be raised 10 to the 10 to get 10? Similarly, if it is 6 to the power 6, suppose it is log 6 to the base 6. Suppose x is there. So 6 to the power x is equal to 6. That means x will be how much? X will be 1. X will be 1 because 6 can be raised to power 1 to get the value 6. So from these we are able to use the laws of the logarithms which we have read just now, and let us see now the next question. The next question is log 8 to the base 4, log 8 to the base 4 minus log 32 to the base 4. Please notice in these that the bases are same in this. So there is no issue. Bases are same. Base is 4 here, base is 4 here. So we can apply log A minus log B will be log A upon B. So it will become what? Log 8 upon 32 to the base 4. It was only possible to write it like this because base is same. 8 4s are 32. So log 1 upon 4 to the base 4. It is log 4 to the power minus 1 to the base 4. I have taken 4 up, so it becomes 4 to the power minus 1. So it will be minus 1 will come here, minus log 4 to the base 4. Again, log 4 to the base 4 will be 1, so it will be minus 1 into 1, that is minus 1. If the number and its base are same, then it will be always 1. The logarithm of the number to its own base will be always 1. Log A to the base A will be always 1. It will be always 1. We have shown you 3 examples of doing that, and we realized that log 10 to the base 10, log 4 to the base 4, log 6 to the base 6, all are 1. Now let us see the next question. Sixth one. In this we have log 8 to the base 4 minus log 32 to the base 8. Log 8 to the base 4 minus log 32 to the base 8. Now the bases are different. The bases are different. So first of all, we will have to change the bases to the same. Now the bases can be changed to like 4. It is 2 to the power 2. It is 2 to the power 3. I can change the bases to 2, the same bases. So it will be easier for us. So we can write it as log 8 upon log 4. And let us write the base 2. Let us write the base 2. minus log 32 upon log 8 and to the base 2. Let us write to the base 2. It will become what? Log base 2 to the power 3. It will become log 2 to the power 2, and it will become log 2 and 2 to the power 5, and it will become log 2 to the power 3 is 2. 2 to the power 3 is 8, 2 to the power 2 is 4, 2 to the power 5 is 32, 2 to the power 3 is 8. Now what do we get? 3 log, I apply the power law, it will become 3 log 2 to the base 2, it will become 2 log 2 to the base 2 minus 5 log 2 to the base 2, and it will become 3 log 2 to the base 2. Everywhere it is log 2 to the base 2, so it will convert into 1. 3 upon 2. Log 2 to the base 2 is 1, log 2 to the base 2 is 1. You can cancel it also, but I am saying it is 1, and minus 5 upon 3. Here also log 2 to the base 2 and log 2 to the base 2 is there. So 3 upon 2 minus 5 upon 3 will become how much? We take the LCM 6, 9, and 3 2s are 2, 5 is 10. So minus 1 upon 6 is your answer. Minus 1 upon 6 is your answer. Now let's see this part of the logarithms. Logarithms express a single logarithm 2 plus log 9 to the base 10 minus 2 log 5 to the base 10. Now we see that two portions have got log, but this doesn't have log, and bases are 10. So what I can do is I can write this as log 10 to the base 10, because 10 to the base 10 is 1, so 2 into 1 will be 2 only, plus log 9 to the base 10 minus 2 log 5 to the base 10. The reason for changing it to log 10 to the base 10 is because everything should be in log, then only I can do multiplication or division. Now it will become log 10 to the power 2. I am not writing bases again, plus log 9. When I am not writing bases, that means it is natural. This is a common logarithm, 5 to the power 2. It will become log 10 to the power 2 into 9 upon 5 to the power 2. We wanted it to be changing into single logarithm. So it will become log 100 into 9, 900 you can write down, or you can leave it here also. 900 upon 20. Let us cancel that, whatever we can cancel. 10 into 10 into 9 upon 5 into 5. So 5, 5, 2, 2. So it will be log 36 to the base 10. Log 36 to the base 10. Because 5 2s are 10, 5 2s are 10. There were 2 10s, the 2 5s. They'll give you 4 in here. 25 into 100, 25 4s are 100, 4 9s are 36. We got log 36 as the answer. Now let us see the next question in this, which is, it says prove 16 to the power log 3 is equal to 9 to the power log 4. They are equal. We have to prove them to be equal. What am I going to do? I am going to take logarithm of both the sides. Take the log of both the sides. Take log of both sides. then I will take log of both sides. It will become log 16 to the power log 3 is equal to log 9 to the power log 4. There is no base given, that means common logarithm is there, that is log base is 10. Log 3, the power term will come in the beginning into log 16 will be log 4 into log 9. Let us calculate both sides. Log 3 is here and this is log 4 to the power 2 is equal to, or you can write 2 to the power 4 log 2 to the power 2 into log 3 to the power 2. So it will come 4 log 3 into log 2 and this will be 2 to the 4 log 2 into log 3. Both sides are equal. 4 log 3 into log 2 is equal to 4 log 2 into log 3. So both sides are equal. You can see that clearly. Now let us see the third part. Prove that. Seven log 16 upon 15 plus 5 log 25 upon 24 plus 3 log 81 upon 80 is equal to log 2. We have to prove the left hand side also equal to log 2 so that left hand side and right hand side are equal. 7 log 16 upon 15. This could be log 16 upon 15 to the power 7. This is the power law. Either power can come in the beginning or the multiple can go as the power. Log 25 upon 24 to the power 5 plus log 81 upon 80 to the power 3. So we have taken all the multiples as power and let us see what do we do after this. Now it is log A plus log B plus log C, so it can be multiplied. That is log 16 upon 15 to the power 7 into 25 upon 24 to the power 5 into 81 upon 80 to the power 3. What we have done is we have multiplied. We have multiplied it. Now let us see what happens is log 16 is there. 16 means 2 to the power 4. 2 to the power 4. It is 3 into 5 to the power 7. 25 means 5 to the power 2. 6 4s are 24 or 8 3s are 24. So 3 into 2 to the power 3. 81 means 9. 9 9s are 81. 3 to the power 4. And 80, 16 5s are 80, 16 as 2 to the power 4 and 5 to the power 3 and this is to the power 5. So let us see now what do we get. Log 2 to the power 4 to the power 7 is 2 to the power 7 4s are 28. 3 to the power 7 into 5 to the power 7 into 5 to the power 10 upon 3 to the power 5, 2 to the power 3 5s are 15 into 3 to the power 3 4 3s are 12. 2 to the power 4 to the power 3 is 2 to the power 12 and 5 to the power 3. So we have basically expressed them in terms of powers of prime numbers. 2, 3, 5, 2, 3, 5. 2, 3, 5 all are prime numbers. Now it is 2 to the power 28 here. It is 2 to the power 15 and 2 to the power 12. 15 and 12 will be 27. 2 to the power 27. It is 2 to the power 8, 28. So it will be log 2 to the power 28 minus 27. Because in the denominator I have 2 to the power 15 and 2 to the power 12, 2 to the power 27 I have taken up. Then it is 5 to the power 10. Let us see in the denominator what are the powers of 5. 5 has got power 7 and 5 have got power 3. 7 plus 3, 10, so 10 go here, minus 10 into. What is the, here 3 has got power 12 in the numerator and in the denominator 7, 5, 12. Just let us check 2 to the power 28 again, because it is coming 2 to the power 1. It could come 2 to the power 0, everything will be, we can get, let us see what do we get. 4, 2 to the power 4 is 16, 2 to the 4, 2 to the 8, 2 to the 16, 7, 28. Here 2 to the power 3, 8, 8, 3 is 24. This 2 to the power 4 is 16, 16 5, 18, it's alright. So this 5 to the power 10 minus 10 is 0, 3 to the power 12 minus 12 is 0. So it only will be left log 2. Will be left log 2, because this will be 0. 5 to the power 0 is 1, 5 to the power 0, 3 to the power 0 is 1, and 2 to the power 1. So log 2 is your answer. Thank you.